Tonight we continued with estimating with scientific notation. Now, this was also a good review of actually determining scientific notation, because you'll notice from your homework that you still had to calculate scientific notation, utilize calculator notation, but we also incorporated the concept of estimating scientific notation. So for problem number 1, which I realize isn't numbered for you, but for reference in the video here, we're going to call it number 1, is 43,000. Now we want to write that in scientific notation. Remember, we talked about the use of commas and making this easy. The comma tells us, okay, that's 3 decimal places over the comma, and then one more would get me to between the 4 and the 3. So that's a total of a shift of 4 decimal places. So 4.3 times 10 to the 4th power. Now, it then asks you for an estimated value of the scientific notation. And the estimated value of the scientific notation, since my 3 is less than 5, we're going to go ahead and keep the value 4 as my rounded whole number times 10 to the 4th power. Now our calculator notation is essentially the same as our scientific notation. The only difference is, rather than saying times 10 to the 4th, we will end up with 4.3 E 4. And then finally our estimated calculator notation, 4 E 4. And so you'll notice as we progress through these that they will go rather quickly. Now let's look at another example problem, one that's going to go in the opposite direction. So the third one down, 2.3 E negative 7. Now 2.3 E negative 7 is read 2.3 times 10 to the negative 7th power. So my 2.3, we know our decimal is going to move to the left 7 times. 1, 2, 3, 4, 5, 6, 7. So that's my new decimal place. And in each of these loops, we end up with a 0. And as mentioned in class, I do like to have a 0 prior to the decimal place. It just helps me to make sure that I know exactly where you anticipated that decimal place to be. So my standard notation is going to be 0.1, 2, 3, 4, 5, 6 zeros, 2, 3. Now for our scientific notation, since we started out with a calculator notation, writing it in scientific notation is a piece of cake. That's going to be 2.3 times 10 to the negative 7th. Well, now we just need our estimated scientific notation and our estimated scientific notation and our estimated calculator notation. So again, our 3 is not greater than 5, so our value will round down to 2 times 10 to the negative 7th power. Our estimated calculator notation, 2e negative 7. Now, you should notice that once you've gotten the pattern, working through that front side of the sheet was really rather easy and should have been a rather quick assignment. The back side then, same process, so still rather easy. A little bit more attention is needed towards determining that original scientific notation. So let's look at one of these problems. 332.55 times 10 to the fourth power. Now this is what we talked about yesterday, was almost scientific notation. We notice that it's almost scientific notation because we have a base 10 with a power, and we have a value to the left of it, but that value just doesn't have a leading term that's between 1 and 10. So we want to ignore this power right now and just deal with the term so that we can give it a base 10 and move the decimal. So I'm going to move the decimal 1 place, 2 places to the left. If I do that, and again ignore the 10 to the fourth, that would be 3.3255 times 10 to the second power. And now I'll reintroduce times 10 to the fourth power. And so we should remember that 10 to the second power times 10 to the fourth power is the same thing as saying 10 to the 2 plus 4 power. So that's 10 to the sixth power. And we drop down our leading term that was a value between 1 and 10. 3.3255. Now finding your estimated scientific, your calculator notation, and your estimated notation, calculator notation should be rather easy from that point on forward. Let's look at one more example. 0.0033255 times 10 to the fourth. Now again, we need to figure out how to move this decimal place 1, 2, 3 units to the right. You can certainly use the same steps as the previous problem. We're moving 3 units to the right. So that would be 3.3255 times 10 to the negative third power times 10 to the fourth power, which would simplify to 3.3255 times 10 to the first power. Now an alternative way of doing the exact same thing is remembering that when we moved the 3 decimal places to the right, that gave us a negative 3 value. 4 minus 3 was 1, and so we could jump straight to our solution of 3.3255 times 10 to the first power by essentially doing the exponent addition in our head and skipping showing this work on paper. I find that showing this work helps me to make sure that I don't make mistakes. So if you're concerned that you may make mistakes also, feel free to use this method. A fourth alternative method that I will show you we're going to stop right there.